I'm Reuben. I'm a product manager at DBT Labs, and I'm here to tell you about all of the exciting things that we've been building to enable cost-effective data operations. And I spent a long time thinking through what was the most exciting thing I could present on. And obviously, as you can see, I settled on an insurance company. And so today, I'm actually Reuben, your favorite insurance agent. And so let's talk about the situation. I'm going to talk to you about insurance company Dagshaw's DBT setup. Dagshaw Insurance just completed a migration all the way to DBT Labs. And as a multinational insurance company serving millions of customers, having the right data at the right time is really important to our business. It lets us adjust our premiums, hedge risk, and then scale our dependency-aware insurance across thousands and even millions of customers. And so, as a data team, it's our job to ensure that there's always fresh data to power the decisions. And like many customers, as we were setting up, we split our jobs across the domains, across areas like our premiums, our coverage, and our customer analytics, so that we can ensure we meet the different SLAs of the business. And with these 7 different jobs set up to run at varying times across production, we were finally ready to turn it on time and on policy. But like every company with thousands of models running in each job many times per day, this really caused our data warehouse costs to explode. And as an insurance company, we don't like explosions.
We all do dumb things. Spending too much on your data warehouse doesn't have to be one of them. With DBT Fusion, just 25 minutes could save you 25% or more on your data warehouse bill.
And so with that, let's talk about a few ways that we can save you some money. First up, I want to talk about state-aware orchestration, or SAO. And so at Dagshaw, we think about SAO as your policy against runaway data warehouse costs. And let's talk about what that means. When I started working on this almost a year ago, I really became obsessed with the idea that too many companies were building too many models when that rebuild could lead to the exact same outcome for those models. And like we saw in the keynote yesterday, many of us run jobs every hour, every 30 minutes, because it's better to overbuild those models than it is to miss out on incorporating new data across our models. And so today, when you run a DBT build, everything that's selected is simply built, even if nothing's changed. And this obviously leads to unnecessary model builds for the same outcome, and it leads to the pain of maintaining selectors across thousands or tens of thousands of models and coordinating tens or even hundreds of jobs. And so with Fusion, what we really did is rethink the behavior of DBT build. And so we know in real time what code or what data has changed, and then we can only rebuild what's actually needed. And with this, we're seeing our customers reuse 30% or more of their models on every DBT build. And so really the question is, how does Fusion do this? We do this by moving DBT from a stateless piece of software to a stateful engine that keeps real-time model state. And if that sounds exciting to you, great, me too. If that sounds a little confusing, what this really means is that as the jobs are running, we keep a real-time cache of the entire environment with every model's hash, data, and code state. And so when you run DBT build, if nothing's changed, we simply don't build it, and you get lower costs. And it means that as we're running through the DAG, we can make real-time decisions at each model of whether to build it or whether to skip over that. And so it no longer matters which job is running which model. And then finally, as you think about jobs building and trying to avoid the same job running the same model at the same time, we keep a lock on the models on the DBT side. And so if 2 jobs try to build the same model simultaneously, we're going to wait for the first one to finish and then make that intuitive decision about whether anything's changed and whether we should rebuild it with that second job. And so with state-aware orchestration, instead of the 7 production jobs that we had previously, we've been able to simplify everything down to that single job And that single job simply runs every 30 minutes with state-aware orchestration enabled as part of those Fusion cost optimization features. And so if we go ahead and we run this job, we're going to see that on the first run of this job, just as you'd expect, we're going to build every model where either the data state or the code state has changed. And so we can see here, if we go into our dbt build and our new structured logs, we see those 13 models successfully built. And we see the reason they were built is because there were new changes detected on something upstream of that data. And now, you can imagine if we were to run this again on a second run, this time we're only going to build the stuff that's actually changed. And so on that second run here, we can see, again, going into that dbt build, that if we go ahead and we look at our claims model here, right, we're going to see that, again, we detected new changes and therefore built it. But we can go to that reuse table and see in our premiums model, because there was no new data to incorporate, we simply reused that model and didn't have to build it anymore. And simply by turning this on, we're seeing our beta customers save 10% plus on their data warehouse compute. And really, it's been awesome to see, right? It's been awesome to see that with the switch of a button, you can change the behavior of your jobs to be more intelligent and to run only what's needed. And what we wanted to build next is the idea that we built safe default behavior. We build things whenever there's any change to incorporate, and we build things straight away. And I wanted to talk about how you can use these advanced configurations to further tune what you build. And instead of just that 10%, the dbt internal analytics team was able to go for an incremental 52% from these advanced configurations. And so really what these advanced configurations do is they help you customize the behavior of both your sources at the top of the DAG and then your models as you build down that DAG. And so they help you deal with situations like the case where a model may be needed less often than the sources refresh, but you don't want to slow down a single source because there are other parts of the DAG that need to incorporate that data. And so with advanced configurations on the sources, you can really define what it means for a source to be fresh. And so by default, we're asking the info schema or the metadata of the warehouse, when was that source last updated? But if that doesn't work for you, you can tell us a custom column, which could be whatever column holds that data information, or even a custom query. So you can go and reference perhaps an iceberg table or incorporate your own definition of a number of rows and a date that needs to be passed in order for a source to be considered fresh. The next thing here is that as you think about controlling that level of refresh at either the project or the model level, is that you can create SLAs for those cases where sources refresh more frequently than the business needs the data. And so you can imagine putting a build after of count 2 or every hour, right? Or you could even do a build after that was conditional on 2 hours for Mondays and Tuesdays, and then 5 hours across the weekend. And what this does is even when there's new data to incorporate into there, we're not going to build that until there's both new data and it has been at least that long since the last time we built that model. And then finally, you can think about as you traverse across that DAG, how many things do you want to wait for to update it before you go and build it? And so by default, we take the safe option and we build it whenever there's any new data on an upstream. But you can also say, I want to wait for everything to be fresh, or perhaps don't set freshness on some of those sources, so you're only waiting for a subset of those. And so with these advanced configurations, because they exist as part of that YAML config, you can apply them anywhere across your project. And so you can think about, in this example, simply applying that across all of our marts, right? And then putting that default, overriding that default into a 2-hour build after, and waiting for all of the upstreams to be updated before we go and build anything. And then because we may not want that default across all of our models, we can also jump into any of the individual models in that marts folder and say, put a 2-minute build after on those, or a 5-minute build after. And what this really means is we can codify our build logic that previously had to live in 5, 6, or 7 individual jobs into the actual YAML code itself, which is both source controlled and lets us easily propagate it across the entire DAG. And as we keep building here, we're really thinking about, now that we have the semantic understanding through the power of Fusion, what else can we build that is going to give you automatic cost savings across your project? And let's talk about efficient testing. And so, as I assume they say in the insurance business, better coverage begins with a better test. And so today in DBT, we run a test, much like we run a model, at the end of every successful model that builds. And with efficient testing, what we're doing is we're really changing it to only run tests when they're needed. And so if we have a unique test on our stage customers model, traditionally we're going to run that same test again on our dim customers model. But the idea is, if there isn't any logic in that dim customers model that invalidates that already passing test, then we shouldn't run that test again, we should simply reuse it. And doing this can really speed up runtimes and reduce costs because we're going to avoid the unnecessary computation of all of those tests across the lineage. And the question is, how do we do this, right? How do we guarantee that those tests, which are super important to data quality, are still going to pass? Really using the semantic understanding of the SQL, we don't skip a test and reuse them just because it's passed upstream. We skip a test and reuse them because we can statistically guarantee that that test will pass. And then when we do run tests, we combine all the tests we want to run, and instead of running them one at a time against the data warehouse, we put them all in a single query and run them all as a batch to further increase the efficiency across our compute. And so, much like state-aware orchestration, you can simply turn on this efficient testing feature, and then as you run, you're going to see that tests that pass that we don't have to use again, we can simply reuse those tests rather than having to run those again against those data models. And finally, I really want to talk about how you can take these results and prove them both to yourselves and to the business you work with. Because after all, if you don't have a receipt, you probably shouldn't bother submitting a claim. And so with SAO, we can show both models reused across the entire account, so you can see the impact across your projects, and then on individual jobs, so you can think about how you might fine-tune those advanced configurations. And then, if you really want to go above and beyond, you can also write these costs directly out into the data warehouse through our new package. And by doing that, you can get into the dollar or credit terms of the exact impact of reusing these models. And obviously, more importantly, you can make friends with the finance team so that when the time comes to ask for another headcount, hopefully you get it. And so as we keep building here with the power of Fusion, I want to talk a bit about what's next. Looking ahead, we're really working on bringing some of that cost data you can now run against your warehouse directly into the DBT platform to make it easier to analyze and attribute those savings to the changes you make in your project. We're thinking about column-aware CI and how to create an even slimmer set of CI using the power of Fusion. Now that we have a semantic understanding of how the columns flow through that code, we can be even better about narrowing the changes you need to test, giving you both faster development when CI runs faster, and then less cost because you're building less in those temporary schemas against the data warehouse. And then we want to create AI agents to help you automate those advanced configurations and save you both time and money across your projects. And then finally, we're going to keep investing in further automatic cost savings. As we saw with efficient testing, there's a whole lot more we can do here when we optimize how things run based on the warehouse-specific adaptations we're going to get from the adapter. And so at DBT, we're really excited to help save you all some money. And in terms of next steps, really to think about here is that we need Fusion for these to work. And so the first step is to check Fusion conformance and get ready for that upgrade. Next, it's about thinking about the SLAs across your data and thinking about where there are areas where you may want to slow down or speed up the specific builds under state-aware orchestration. And then finally, if you want to spend more time with me and the DBT engineering team that built this, come and join us tomorrow at the DBT Product Roundtable for even more in-depth discussions. And so, thank you so much for coming, and happy to stick around for any questions.